Emmy Noether, considered the greatest of all female mathematicians up to her time, was born on March 23, 1882, in Erlangen, Bavaria, Germany. She was the first of 4 children of Max Noether and Ida Emily Kaufmann. Her younger brothers were Alfred, Fritz, and Gustav Robert. Emmy's father was a research mathematician and a professor at the University of Erlangen, and consequently, Emmy and 2 of her 3 brothers showed their passion for sciences. At first, Emmy had planned to be a teacher of English and French. Noether graduated in Erlangen. In 1900, she passed the examination of the state of Bavaria that certified her to teach English and French at a school for women. Soon after becoming a language teacher, Noether decided to pursue mathematics, which was then considered as a challenging path for a woman. She took mathematics classes for 2 years from the University of Erlangen, after obtaining permission from the German professors. In 1903, Noether joined the University of Göttingen after passing the matriculation exam. She attended lectures of leading mathematicians like Minkowski, Hilbert, Blumenthal, and Klein. At both universities, she was a non-matriculated auditor at lectures. Since at the turn of the century, girls could not be admitted as regular students. Then, she joined the University of Erlangen for her doctorate degree, and in 1907, she was awarded a PhD in mathematics. Her sponsor, the algebraist Gordon, strongly influenced her doctoral dissertation on algebraic invariance. Her divergence from Gordon's viewpoint and her progress in the direction of the new algebra first began when she was exposed to the ideas of Ernst Fischer, who came to Erlangen in 1911. From 1908 to 1915, she worked at the Mathematical Institute of Erlangen without pay, and started her researches there. Felix Klein and David Hilbert invited Noether to join the mathematics department at the University of Göttingen in 1915. Although she was criticized by many for working at the university, she lectured students for 4 years under Hilbert's name. She was given the title private docent, which permitted her to lecture in 1919, but she was still not paid. In 1922, Noether became an associate professor, receiving a modest salary for her service. Despite her brilliant works and knowledge, she was not given the status of a professor, as she was a woman, a Jew, and a social democrat. During the years 1928 to 1929, Noether became a guest lecturer at the University of Moscow. She taught at the University of Frankfurt in 1930. In 1932, she gave a lecture in Zurich at the International Mathematical Congress. She was a member of the Göttingen Mathematics Department till 1933. When Nazis took over, she was unable to continue her profession in Germany, and so, in 1933, she moved to the U.S. and taught at the Brigham Young College in Pennsylvania as a guest professor. She was paid a full salary here and was accepted as a proper faculty member. She also taught at the Institute of Advanced Study at Princeton. In terms of her personal life, Noether never married, but she had many friends who were colleagues and fellow mathematicians. Her closest friend was Anna Perl-Wheeler, a fellow colleague in mathematician at Brigham Young College. Hermann Weyl was also a dear friend of hers at Brigham Young College. Noether was diagnosed with an illness which she spoke of only to her closest friends. She had to overcome a surgery to remove a uterine tumor, but she died of a post-operative infection in 1935. Noether's ashes were buried near the Brigham Young Library, so her legacy in the field of mathematics will always be remembered. From 1907 to 1919, she dedicated to work in the field of algebraic invariant theory, Galois theory, and physics. Noether proved two theorems on the connection between symmetries and conservation laws that were important for elementary particle physics and general relativity. The failure of local energy conservation in the general theory was a problem at that time that concerned physicists such as David Hilbert, Felix Klein, and Albert Einstein. And Emmy Noether solved this problem, and her theorem became one of the most significant contributions in the development of modern physics. From 1920 to 1926, she concentrated on the theory of mathematical rings. She developed the abstract and conceptual approach to algebra, which resulted in several principles unifying topology, logic, geometry, algebra, and linear algebra. Her works were a breakthrough in abstract algebra. Two of the generalized structures with Noether related to the ideals are the group and the ring. Her paper, Theory of Ideals in Rings Domains, published in 1921, became the foundation for commutative ring theory. The Noetherian rings and the Noetherian ideals form part of her mathematical contributions. Her insights and ideas in topology had a great impact in the field of mathematics. From 1927 to 1935, the study of non-commutative algebra, hypercomplex numbers, representation theory, and linear transformation caught her attention and became the primary focus of her research. From 1932 to 1934, she deeply explored into the structure of non-commutative algebra through her concept of product. In 1932, she wrote a paper jointly with Richard Brouwer and Helmut Hasse, where she proved that every simple algebra over an ordinary algebraic number field is cyclic. We'll call this theorem a high-water mark in the history of algebra. In the same year, Noether received the Ackermann-Tobner Memorial Prize in Mathematics, a prize that recognized work in mathematical analysis. Emmy Noether wrote some 45 research papers and was an inspiration to Max Düren, Chun-Tse Sen, and Olga Telsky-Todd, among others. The so-called Noether school includes some algebraists as Hasse and Schemler, with whom she exchanged ideas and whom she converted to her own special point of view. She was particularly influential in the work of B. L. van der Waerden, who continued to promote her ideas after her death and to indicate the many concepts for which he was indebted to her.